Thanks. Hi, guys. Everybody, how are you guys doing? It's a big room, so if you guys want to get close, I'm going to, we have some code, so hopefully you guys will be able to see it from the back, but I'll try to make sure to be verbose and type slowly. All right, so I just want to introduce the product and myself really quickly. Redis, how many people use Redis? All right, okay. All right, maybe we can skip a couple of slides. How many people use Redis Enterprise? Nobody? Okay, that's good. That's good. We're fairly new in database years in terms of age, but it's, I'll explain a little bit of the product and the architecture and how it actually works with Spark. And then we'll take a look at real-time machine learning. I just want to show you how we do it. We had a couple of talks, so I'm going to build on some of the things that they've actually said already. But if you haven't seen any of them, I'm going to give you kind of the quick recap of some of the talks that were going on as well. All right, myself, I'm a database geek. I have been in the industry for a very long time and built quite a few products. I always like to do this every time I present, just so I can see every product that I built and how it's doing in the market. But I met this guy called Michael Stormbreaker a long time ago and changed everything. I decided this is what I want to do. I started with a database called Illustra. Anybody remember Illustra? No? All right. Anybody remember Informix? Okay, a few people. Good, good. I worked on Informix for a while. Anybody use SQL Server? All right, I spent a lot of time on that product, so if you guys want to come punch me afterwards, if it failed you in some regard, you're more than welcome to come by. And Azure SQL? Excellent, all right. Couchbase? One or two, okay, all right. And Redis. Obviously, this is the best one, and I'll tell you why. So, all right, I'm going to do a quick introduction to the architecture just so you guys understand what the engine looks like underneath. And I just want to tell you a little bit about the company and the products that we develop. But then I want to spend most of the time just talking about what real-time machine learning looks like. We have an engine that it's an in-memory database. That's what Redis is. But it's very extensible, and we've been building on the machine learning front quite a bit. I'm going to show you two specific examples, but we'll start with machine learning using Spark. We'll take a look at how that's done and what the cycle looks like. There was a deep dive talk on that yesterday, so hopefully you guys have seen it. If not, maybe you'll time travel back and see it. And then I want to show you what real-time training and machine learning inside Redis looks like. And we'll actually train a model very quickly, and then we'll run a couple of questions, and it's all about Titanic. So I'm going to end the conference on a slightly dark note, and we'll find out what your chances of surviving Titanic is. Does anybody, how many people know about Kaggle? All right, so maybe you guys have seen this example, maybe you haven't, but we'll take a look. All right, so we are the commercial company behind Redis. We developed the open source product with Salvatore Sanfilippo. And we build around the core technology a capability that scales it out and provides enterprise capabilities called Redis Enterprise. And that's the product that we kind of essentially build side by side with the product. They look very similar, so I'm going to zoom into Redis architecture, and then as I zoom out, I'll tell you what we actually do. But the company is fairly young in database years, and we just started with some of these technologies, even though Redis has been around for a little bit. This Redis Enterprise technology, what it actually does, it takes the open source Redis, changes it slightly to allow us to scale and give high availability and better performance. We also provide it as a set of cloud services if you want to just run it by yourself run it in the cloud, where the only thing you have to tell us is where exactly in which geography you want to provision the service. Or you can run it on premise. It's the same product. We have one code base, and we kind of provide this. We've got We've been running this for a while, so we've got about 250,000 Redis databases that we run in the cloud. We've got about 600 new databases a day. So, and it's well connected with the Databricks cloud, so you can actually use them side by side as well. So on intro to Redis, some of you said you already know it, but I'll just kind of zoom into the architecture of this product. This is what makes it unique. It's an in-memory database. It's actually a single-threaded engine. It's got an event loop at the top. All the events come in. These are commands that you would either use to manage your database or to run data operations. It's kind of like all the other databases that you know in one regard. It's still, gets and sets and operations. On the left side of this, this kind of architecture diagram in the process space that you see, these are command handlers and dispatchers that actually take your command, make sure that it's actually well-formed and correct, and then we execute them within Redis. On the right side, we've got some background services that run. So when I say single-threaded, I'm oversimplifying. There are things like replication or file save that we do, or expiration management, et cetera, within the database with all of your keys that we have to kind of do as background tasks. So for most intents and purposes, it's a single-threaded engine, and it's lock-free. And this is what makes Redis very fast, right? So this is it. The darker gray sections that you see is the storage space, and that's keys and values. One thing that's unique about the keys and values in Redis is that it's not only keys and values, but it's keys and structures. These structures I'm actually going to get into the details of in just a few minutes, so I'll hold off on what they look like. But fundamentally, the data model of this platform is different than every other database you've actually looked at. We don't use tables. We don't use JSON. We actually use structures to manage your data. And the disk subsystem essentially is there to provide durability, though the product that I'll show you next, which is Redis Enterprise, also comes with replicated durability. So you can actually replicate this data to multiple nodes, and if you lose one or it catches on fire, one of those nodes disappear, you're safe. You can continue to use it. So disk persistence and replicated durability. Redis Cluster essentially is the Redis Enterprise product that we provide. All nodes within the cluster look the same, except that we actually take those single-threaded engines and package a lot of them into their node. And the blue layer of that cake that you see on each one of the nodes, that's the kind of secret sauce and the magic. There's cluster governors, which look at which nodes are up and running and which nodes are down, manage failover, et cetera. It just kind of orchestrates the entire cluster. We have got a proxy that kind of hides the complexity. So Redis and Redis Enterprise are essentially completely compatible. If you've got a Redis app today, you can just change your connection string and everything kind of works, and we can scale it out to multiple shards. But all of that complexity is hidden behind some of these blue tiers. And then we get a REST API and all the stuff that you need to manage it. All right, so why do people use Redis? Just in case you haven't bumped into us before, well, the first reason is performance. We're in-memory database, as I said, and we typically do things in sub-millisecond latencies. We'll look at training even as part of the demo, and I'll show you how it actually happens in sub-seconds, right? Obviously, we're able to do that just by the laws of physics and the ability to kind of train on. And we can actually parallelize across all of the shards, but at the same time, it actually gives us a great advantage. The structures is the second reason. So I mentioned this a little bit ago, but one of the things that make it very unique, that Redis is so unique, is that it's structures. So instead of having tables, which is the way you express your problem to a relational database, or documents, which is the way you express your problem to a document database, we actually provide structures. And all of these structures can be hanging off of any number of keys. So within a single database, you can mix and match these things, and you can work with them directly. And that gives you simplicity to design and express your problem. If you want tables, there are structures like tables. If you want JSON, there are structures like JSON in Redis. But there are many others. And then the final one is extensibility. And this is what allows us to do the machine learning that we will talk about today. I'm going to show you those two examples afterwards. But essentially, all of these structures can be extended. You can also define your own structures, and there's words on top of each one of these structures that allow you to manipulate them. So you will see me import a neural network module into Redis, and it gets its own commands, and we can just run them as Redis commands directly in there. Or a random forest module that actually, or a linear regression module that can have its own verbiage directly on top of that data. And all of that data can be mixed. So as I said, the most unique thing about Redis is the way it actually structures its data. So there's familiar data types here, but if you're thinking about your programming as a set of capabilities within your language where you put square brackets around some variable name and it suddenly becomes an array, it's very similar in Redis. This is the way you express your problem into Redis. And these are the data types that you can work with. So sets, sorted sets, geosets, bitmaps. These are all the things that we all kind of use in our application logic, and you can use them directly in there. Now, the interesting part here is the modules, and this is kind of, we have a C-based engine. You can use to write any of these languages that are listed up here to write additional modules. But what we've been doing in the last year is working with the community to get a lot of these additional data types into Redis, and they can all run using the core. Now, one of the important things about modules and the way we actually keep them fast is that we don't abstract them to some other data type within Redis. There's no, if you guys work with the XML implementation of a database or JSON implementation of a relational database, I worked on one of these things, to be honest, but what we used to do is take those things, shred them into tables, because that's what the engine understands, right? If you talk XML to me, I'm actually going to convert it to the language that I understand and then talk to you. But in Redis, the modules themselves are data types that you directly implant into the heart of the product. So we don't abstract them to something else, and that's why we can actually keep them fast. So here's a couple of examples of what some of the modules look like. There's a neural Redis module, which we will see a demo of in just a second. Redis Ml, there was a talk about this, but it essentially works with Spark and uses Spark as a training engine, but then can actually use the model that's generated to generate recommendations for the applications. Redis Search is just for searching. It's an indexing module that can do inverse indexes for text search or skip list indexes for structured data, like search for a range of salaries or something. ReJSON, that's a JSON data type where you can actually sniper shoot specific attributes of JSON. If you want to read an attribute out of 50, it actually gives you a whole bunch of additional words that doesn't exist in Redis. Time series, graph, these are all the things that we generally see our customers use. And these are some of the modules that are out there. There's more than 50. We're getting a lot more, so encourage all of you to take a look at them. All right, so let's dig into machine learning with Redis. The first thing I'm actually going to do is show you one way in which you can do machine learning today. This was the conversation in a previous talk yesterday, so in case you haven't seen it, I'll give you a quick summary, but if you've seen it, this may be a little bit of a repeat of the information, but this is very typical. We've got a couple of customers who actually do this. So what happens is Redis is an in-memory engine. Obviously, we are where the data is born most of the time because interactive applications will push their data to Redis. Spark or any other machine learning environment can actually use us as a data source. So that's what you see on this side on one. So people will actually read, the machine learning engines will actually read from us. And then they'll do the training. This is a long-running process. We're generally looking at a long batch operation, so we're very happy to hand it off to engines like Spark to do that. But then at the end, people will actually save the model that they generate into Redis. And this is possible not because they can express their model in the set of data types that I've shown you, but it's because of a module called Redis Ml. So this module that we load into Redis supports models like random forest or linear regression. You can actually take the model, instead of saving it to HDFS, you can actually send it through a connector called Spark Redis Ml connector in Spark directly into Redis. Now, once you do that, you can actually serve the recommendations directly out of Redis. And the verbs that you will see here will be things like ml. Or it will be something like forest.run. And you can provide my attributes, a guy with 2 kids, lives in San Francisco, blah, blah, blah. And then you can actually get recommendations back on what type of things could engage this person directly out of Redis. So this is quite common. In fact, last week we were at Redis Conf, and Databricks was nice enough to come in and do a keynote on specifically how this combination actually works. Now, this combination with Redis ML is quite popular. It's actually been there for a while. But I still find that a lot of people understand the process of serving slightly differently. So I'd like to divide this kind of training and serving phases into chunks and tell you why Redis is a better way to serve these machine learning models. So in the training phase, this is the first phase of the problem. As I said, we actually were happy to hand that problem off to the experts who actually know how to do this stuff. But after training, you generate this model. And the thing that you need to do after that is to have an application that generates the predictions or recommendations at the other end of this, right? So for most people, or for some people, this could be Spark. The problem with that is Spark is not built for the interactive application. So if I show up on a website, my patience is going to run out in about a couple of seconds. If you can't really serve me something very, very quickly, you're just not going to have the chance to engage me well. So in fact, we actually talk about this quite a bit, but doing recommendation generation out of Spark, we can easily show the difference between the two. And there's a good notebook that I encourage all of you to kind of take a look at on the Spark side that you can walk through that shows the results between the two, et cetera. So this is what Reynolds' demo was last week. Now, for other people, because Spark may not necessarily be a great interactive database to serve recommendations out of, or an engine, people will actually write homegrown solutions, and they'll actually develop code. You can actually take these models, if they're fairly small, and plant them in the actual application code right next to it. But then there's a couple of problems. The problem is what we find. We actually work with a company who does recommendations on CNN for the articles, and the next set of articles you should be reading. We've all looked at, but the problem is if your machine learning model is not precise enough, you may actually display something fairly insensitive, like an article about a female achievement can actually be coming with a recommendation at the bottom that shows a dead animal or something like that, right? Something inappropriate like that. So what we see is there's a need to actually make the models more and more precise, and when you do that, the size of this thing grows. Now, if it's kilobytes, megabytes, it's not a problem. You can actually embed that in the server in the front end, but if it's not, then it becomes quite expensive to repeat this on every application server in the front end. There's also scaling, HA, a whole bunch of issues that we're used to handling because we're built as a database plus caching tier that can actually serve the mission-critical kind of interactive application. There's also a whole bunch of problems about hosting different types. Typically, what I find is that machine learning is not done by just one machine learning model, but it's the combination of many that gets amalgamated into a recommendation, and data scientists like to try and experiment with what combinations work for which persona is the best. So if you've got many of these machine learning models that you're trying to manage, and they're all in different languages, Redis can actually be a unifying force to allow you to do all of these things together. So these are all the things that really come up. There's a longer list here. I'm not going to go through all of them. But because of that, we find that it's actually more interesting to use Redis as the serving tier when it comes to machine learning models. This is actually going back to the example that I was talking about, the insensitive article that I was talking about. Actually happened here. This was a company that was serving about 20,000 ads per second. We call them ads, but they're recommendations. There's quite a large number of campaigns that they actually run. It's about 1,000 forests, 15,000 trees in each forest, et cetera. So if you look at, I'm not going to go through the calculation in great level of detail here, but all I want to say is, look, it's quite an expensive operation to run this on AWS. Right? It takes a lot of cycles to generate the recommendations for these individuals who show up on the site. And unfortunately, not every recommendation makes money, so you better make recommendation generation very, very inexpensive so you can actually do many of these things without breaking your neck. Right? But when you put Redis into the mix, we can actually take the computational capacity. So what we can do is take it away from all the front-end servers, put it into a centralized database server, and what we can do is we can actually run the same kind of load on, instead of 1,200 machines, in 35 machines. And Redis is known to be able to do millions of operations a second, even on a single-threaded engine. So for us, this is actually what we do and what we tune and what we instruction count for. So these are the things that actually work well. Now, this was the example that was shown yesterday. So either travel back in time or just pull up the video. And Shai will actually talk deeply about what the verbs are and what kind of operations you can actually do on the Redis Ml component. And this is a very common way that people actually do it. But there's a second way that I want to talk about. And the second way is actually a lot more fun and interesting. But what we actually see is, for a lot of people, there's also machine learning problems that they like to solve on the device or on the edge, where there's really not a lot of computational capacity. Maybe the data is actually smaller. It's much more local. And they want to be able to do training and resolution and recommendation generation right there on these kind of edge devices. And this is actually going to be very powerful for something like that. So in this model, instead of what I showed you earlier, which is to hand off the training to an engine like Spark or TensorFlow or something else, what we actually do is we import the data using another module called Neural Redis. This was from Salvatore. You can actually find it on GitHub. What we actually do is we import the data. We do the training inside Redis. It actually takes very little time to do this. And then we can actually serve the recommendations directly out of Redis. So this cycle, let me kind of just go through the two. So reading of the data, training, and saving of the module, the machine learning model, and the neural network is all happening within this one cycle. We're actually going to see it happen less than a second in about, not in seconds, but milliseconds. This is what we'll actually see. And then the serving can actually directly happen there. All right, so let's talk about this module a little more. I just want to kind of unpack what this is. There are many other examples that I'm not going to touch on. There's a couple of other modules that actually do machine learning, like the Tensorflow module is a good example. It just looks like the first one, very similar to it. But this one, in my view, actually creates an interesting set of capabilities for you to be able to do machine learning in real time, very fast, and be able to answer some questions really quickly. So what this module provides is a very simple API. It actually gives you the automatic data normalization training right there. But what's also interesting is that because we're a single-threaded engine, we had to do some extra work to make sure that it actually does not block you while you're generating recommendations. You can actually continue to train the model. So it's got some trickery inside that allows you to do training in parallel without impacting and disrupting your serving. And the modules API allow us to do this kind of, good citizenship kind of scheduling inside Redis. So it will continue to serve recommendations while new set of data arrive. We train on that or retrain on that. And then the next set of recommendations that come in can actually use the new model that we generate. And these are all the things that make it very, very interesting. It's really easy if you know how to use Redis. All you need to do is load module and point to the SO file, and this module is loaded. And that's pretty much what I've actually done. So I'm going to show you this kind of darkish demo. Hopefully it won't. We'll try to have fun with it. But ultimately, the data set I have is, actually, let me go to the next slide. The data set I have is the survival data on Titanic. We'll take a look at it, but there's a couple of attributes we know about the people who survived versus didn't survive. We'll actually load this information into Redis first. That's the first step. The second step, we're going to run training. I'm going to show you how to run that. And when we actually train, we're just going to get a sample of this data, and we're going to look at that. And then finally, I'm going to pick a couple of victims here to see if we can predict your survival in Titanic. All right, let's do it. Before I begin, I'm going to cheat a little bit and show you what the real results look like. So I just want to attract your attention to a couple of things. One is, if you were a man, you're not likely to survive Titanic. So just keep that in mind. If you're women and children, you've got a better shot. The other thing is, if you're traveling in third class, yeah, you didn't most likely make it. But if you're in the first class or second class, there's something about the second class, women in second class, that actually somehow is weird. But other than that, if you were women or children, you actually had a good shot at surviving. All right, so let's take a look at this demo. Let me start here. So we will, this is right off of GitHub. You guys can actually try this yourself as well. Let me show you what the data looks like. So let's take a look at this first. This is the data that we're going to train on. I've actually already loaded this, so this part I'm going to cheat, even though it's fast. This is essentially a couple of people with an ID. We know what their sex is, ages, what their fare price was. We know about the class they were traveling in, et cetera. So a couple of the attributes. What we're going to do is, this is the app that actually loads it. So it opens the CSV file, and it actually runs the command called nr.create. This is a Redis command that will create the model. And we're actually going to take a subset. So there's some sampling here that we actually do. But after that, it's going to normalize some of this data so that we can take the attributes, train on it, and stop right there. So this is the Ruby application. If you guys are interested, this is also on GitHub, but I won't walk through it. So I've done all of those steps. Where I'm going to start is going to be on Redis CLI. Redis CLI is the command line for Redis. Now I'm connected to the Redis engine that has all of this information. What I'm going to do next is, let's do training. So the data is important, but I haven't trained on it yet. I'm actually going to run the training. The auto stop allows me to just kind of run this and leave. The training will start, but it actually runs so fast that it's already finished. So nr.info, shows me some information about this key. This is actually a command that's part of the module itself. One thing that I will, it's fairly cryptic here, but one thing I'll actually tell you about is this is the total training time in seconds. So it took us about 120 milliseconds to train this model. It also tells me how many items I've actually gone through and how many steps, et cetera. So there's a whole documentation around this if you want to play with it, but the training time was actually very, very quick. Now, the last step we're actually going to do, let me go back, is, so the create and observe at the top here were the two things that we did with the Ruby application. The training was done. Now we can actually generate recommendations. The recommendations take a couple of attributes. So the first thing we'll provide is a couple of ones and zeros that provide the class of the passenger. The second set will mark whether it's a male or a female. We'll capture the age. The companions are, did you have anybody with you? So apparently there's chances of survival that get lower if you've got children with you, et cetera, because there's a lot more to coordinate, or your parents. So there's a whole bunch of things on the ticket price. So why don't we actually just take this guy. Let me just do this for a second. We'll take this guy, which is essentially a first class 30-year-old female that is paid $200 to travel in the first class cabin. So the output actually is the death chances is the first line, and survival chance is the second line. So this person, 97% chance that she actually survived. Good, excellent. It's easy to kind of see if I change the male and female. So these are the two flags. If I change it to male, you can see that your chances of death is about 86%. So you actually didn't make it. It turns out your age actually can be a difference as well, but it's actually better if you're older somehow. Not every answer is going to be the correct one, but this is the idea. And all of this comes directly out of Redis. So the applications that connect using any of the Redis SDKs can actually run these commands, generate these recommendations directly there. And the deployment that we have here, Redis can actually run in as small a space as 2 megabytes, so very low footprint. We actually have a version of it that runs on ARM or Raspberry Pis. You can actually see it. So these are the scenarios where we find that a lot of customers are very interested in doing edge training, et cetera. So this is what I had for the demo. I'm actually going to run pretty fast through this to see if we can finish off. So maybe I hope nobody's going to be upset if I let you go earlier. But this is what the demo is. And we basically looked at what Redis is and what Redis Labs does. But then I show you 2 techniques to use Redis for real-time training. And then we just looked at this neural Redis capability. And basically with that, I just want to give you a couple of resources to go try these things if you want to try them on your own, and close. If there are any questions, I'm happy to answer them. I'll be here for a while. But thank you so much. Thanks for coming.
I can take the microphone to you, like if you raise your hand.
So you mentioned that the training time is like 0.12 and things like that, under a second. Yep. What's the size of the data, and how does it scale with the data size?
So this actually runs on fairly small modules. In terms of number of items that you can actually train on, this was only 200 items. As you actually go through this, scalability, we've actually seen thousands of data points, tens of thousands of data points still stay under a second in terms of training time. And because it is the ability to train in the background exists, you can still serve the recommendations. So I don't know if I can give you concrete numbers. It all depends on the machine that we're running in and the power of what we have. But because it's in memory, we can actually keep them fairly low in terms of training times. And that makes it very, very exciting for the people.
Yeah, so in terms of the model format that this Redis module can take from TensorFlow, Cafe, and all of those open source deep learning frameworks, what model format is compatible with this? Do you take like TensorFlow model and
so
others?
That's a good question. There's a couple of different modules that provide different kind of model support for different machine learning algorithms. The one that I showed you is a neural network that is custom built directly into the training exercise, et cetera, all the verbiage is there. Redis Ml supports random forest regression and linear regression. I'm not an expert on all the other ones, but we're actually continuing to build many more models. What we see is, typically in the industry is that these things actually matter a lot first, and then the other models actually come. But the idea is that we have flexibility to build all the other modules. There's about 6 that I can't remember off the top of my head that we support in Redis Ml. Redis Ml can actually take it from TensorFlow. Redis Ml can take it from Spark, and we can actually support about 6 different types of machine learning models. There's a TensorFlow module that specifically works with TensorFlow, and you can serve the tensors directly out of Redis, just like the way that you see Neural Redis does. So And I'm probably missing a few others that the community has done. But in terms of a list, yeah, this is kind of the list that I can remember off the top of my head. Any other questions? No? Going once and twice? All right.
All right, well, thanks. Give a round of applause.